Good day, everyone. Today, I'll be introducing you to Geographic Information Systems or GIS, focusing on its powerful role in hydrologic modeling. So, GIS is a technology that combines location data, attributes, and analysis functions to help us understand spatial relationships. It has become an indispensable tool in hydrology, enabling us to map and analyze watersheds, rainfall patterns, floodplains, and much more. And over the next few minutes, I'll walk you through the basics of GIS, its applications in hydrology, and how it has transformed this field. So, so what is GIS? To start, let's define GIS. GIS is a geographic information system, a technology that integrates three main components. First is the attribute data. It is the information about specific features like population, land use, or rainfall. Next is location data, or the coordinates or spatial references linking these attributes to a specific area. Lastly is the spatial analysis functions or tools that allow us to discover patterns, relationships, and new information. For example, GIS can map rainfall intensity across a region or the population density in a city. Essentially, it connects data to geography, making it an invaluable tool for many fields, including hydrology. So the question, why GIS matters in hydrology? In hydrology, GIS has transformed how we analyze and solve problems. Hydrology is inherently spatial, as it involves studying water movement across land surfaces. So, GIS allows us to, first, delineate watershed boundaries to understand drainage patterns. Second, estimate runoff during storms or floods. And lastly, create floodplain maps to identify vulnerable areas. For instance, GIS can analyze rainfall distribution across a watershed during a storm, helping us predict potential flooding and manage risks. The next is the components of GIS. So GIS represents data in two main formats. First is the vector data and the second is the raster data. Let's start with the vector data. So vector data are points, lines, and polygons. For example, a rain gauge is a point. A river is represented as a line, and a watershed boundary is a polygon. So a raster data is a grid of cells like an elevation map or rainfall intensity grid. So as we can see in the screen, we have an example or a picture or illustration of a raster vector image. So that is or data. So these formats can help us visualize and analyze geographic data effectively. Additionally, GIS can incorporate temporal data, allowing us to study changes over time such as rainfall accumulation during a storm, just like what I mentioned a while ago. GIS in action. Now, GIS is incredibly versatile. And here are a few examples of its applications. First is for rainfall analysis. Using time series maps, GIS can show how rainfall accumulates during a storm. Next is for floodplain mapping. It can identify areas prone to flooding, helping with disaster planning. And lastly, for urban infrastructure, GIS maps can display water distribution networks or sewer systems, aiding urban planning. These applications showcase how GIS bridges the gap between spatial data and real-world decision making. Now for the growth of GIS in hydrology. The adoption of GIS in hydrology has been rapid, all thanks to the following. First is the availability of global geospatial datasets like soil and land use maps. Next is affordable and powerful computer hardware for detailed analysis. Next, we have the GIS software with hydrology focused extensions. And lastly, for the training programs that help engineers and technicians utilize GIS effectively. These advancements have made GIS an indispensable tool in modern hydrology. Now, despite its power, GIS has limitations that we must consider. For the data resolutions, because in large basins, general data may suffice, but for small watersheds, high resolution data is essential. For the coordinate systems, using the wrong map projections can distort distances and areas, and proper training is very necessary to make the most of GIS capabilities. Understanding these challenges ensures we use GIS effectively and accurately. In conclusion, GIS is a transformative tool for hydrology. It links spatial and temporal data, enabling us to model watersheds and map floodplains and analyze runoff. With its ability to visualize and analyze complex data, GIS has become indispensable in addressing hydrologic challenges. However, its effectiveness depends on proper training, high quality data, and an understanding of its limitations. GIS is not just a tool, it's a bridge between data and decision making. And that wraps up my presentation, and I hope you have um, liked my presentation. Thank you for your time, and God bless.